Welcome to Wildcat Science with Mrs. Haugo. This is Chapter 7, Part 3, and we are studying the axial skeleton, which, if you remember, is the body's axis, and we will start with the skull. The skull is divided into the cranium and the facial bones. The cranium encloses and protects the brain. It provides attachment for muscles that aid in chewing and in head movement. It includes 8 bones, so the cranium is actually an overall word for 8 bones. The frontal bone, the parietal bone, which is on either side of the skull, and the occipital bone, which is in the back, and it goes all the way down. The foramen magnum is in there. And the temporal bones, which are on either side by the ear. There are 2 more cranium bones, and these are better seen through a cross-section cut of the cranium. So this is the inferior wall of the cranium, and you can see like a bat-shaped bone that is the sphenoid bone. And then also there's a little one here. This is the frontal bone, but there's a little one right here that's the ethmoid bone, makes up part of the inferior cranial wall and a little bit of the nasal cavity. So all of these bones are joined together by sutures, and sutures are an immovable joint. So you can see that all these bones were separate bones as an infant, as a fetus, and then they closed up and formed an immovable joint. Let's take a look at some of the pictures of the bones. So here we have the frontal bone and the parietal bone and the occipital bone, the temporal bone, and you can see a little bit of the sphenoid bone, and the ethmoid bone. There are also some depressions and projections I want to take note of. The mandibular condyle, which is a bump we talked about before on the mandible, and then that articulates with the mandibular fossa, which would be this hole here, this depression here. Some new ones are a styloid process, so that is a projection on the temporal bone. And the external auditory meatus is a passageway that goes through the temporal bone. And if you notice, there are some sutures here, like the lambdoidal suture, which is a joint between the occipital bone and the parietal bone. And if you notice, each different connection between 2 different bones has its own name. Also, we're going to be talking about these facial bones. Let's take a look at these bones in a different view. A sagittal section, if you remember, would go through your skull in left and right sections. So in yellow is the frontal bone, and in blue is the parietal bone, the occipital bone, the temporal bone, and then looking here in dark purple would be the sphenoid bone, and in pink, the ethmoid bone. And you can see that this makes up part of the nasal septum. It makes up part of the superior part of the nasal septum. Looking here at some other things we can see, we have another suture between bones, a coronal suture, a frontal sinus, and then there are some facial bones we can see, the nasal bone, the maxilla, and the mandible. As promised, we're going to talk about the facial bones. These are immovable bones that form the shape of your face. They provide attachments for muscles that move the jaw and control facial expressions. They include 14 bones. The maxillary bones, which are up here, the top part of your mouth, palatine bones, which make up the hard palate in the back of your mouth, or the top of your mouth, excuse me. We'll take a look at those in a cross section in a minute. Zygomatic bones, which are in the front of the face and make up your cheekbones. Lacrimal bones, which you have to kind of look in the eye socket, and they are there in the eye socket by your tear ducts. Lacrimosa, that's Latin, tears. Nasal bones, which are these two slender ones that make the bridge of your nose. Vomer bone, which is down here, and that makes the inferior part of the nasal septum. The inferior nasal conchae, which kind of are these little scrolls on the lateral sides of the nasal cavity. And then the mandible. And that is the only freely movable joint of the facial bones. So all bones but the mandible are joined by sutures. And the cleft palate is caused by incomplete fusion of the palatine bone. And so if we look down here, we can kind of see where we have the palatine right there, and it's two bones that fuse together, and if they don't fuse together correctly, that results in cleft palate. Looking at some pictures of the facial bones, we have the mandible down here, the maxillary bones here, the zygomatic bones on either side. We have the nasal bones. We have the vomer, which makes the inferior part of the nasal septum, the inferior nasal conchae here on these little scrolls. And then also we have the lacrimal bones, and a review of some of our cranial bones. Frontal bone, parietal bone, the temporal bone is peeking out there, as well as the sphenoid bone and the ethmoid bone. And then there are some sutures. In here you can see they're showing us the squamosal, the coronal suture, and an infraorbital foramen. And I would like you to take a guess as to the job of the infraorbital foramen. This is an anterior view of an adult face. Let's look at what happens to infants. So the infantile skull is different than the adult skull because the skull is not completely developed at birth, and it has fontanelles, which are soft spots. These are areas of incomplete bone formation that connect the cranial bones. So they are membranous. They are actually made of membranes. And this allows the infant skull to move through the birth canal and kind of squeeze a little bit together more than it could if those sutures were all the way joined together. This also allows for rapid brain growth during infancy. And these fontanelles should close by the second year. So taking a look at a picture of the infantile skull, lateral view. As you can see, the infantile skull has all the same bones, it just looks a little different from the adult skull. The frontal bone, parietal bone, temporal bone, occipital bone, and then these sutures are incomplete. The bones haven't fused yet. There is this soft spot. This is the most prominent one, the anterior fontanelle, and you may have seen that on a newborn baby. And there are also other fontanelles, the sphenoid fontanelle, mastoid fontanelle, and posterior fontanelle. So of note, I had a friend who had a baby whose frontal bones fused too early. So the problem with that is that the skull wouldn't grow fast enough for the brain, and that could cause damage. So they have to, cut the forehead, break the bones, and then sew it back up. And this sounds pretty traumatic, but that happened probably about 10 years ago, and he is a very healthy child nowadays. Moving inferiorly from the skull, we go to the vertebral column. And the vertebral column forms from the skull to the pelvis. It forms a vertical axis of the skeleton, which helps support the head and the trunk. the vertebral column has 4 curvatures that give resiliency. So first up, there is the cervical, then the thoracic, the lumbar, and then the pelvic, which is the final curvature. Openings in the vertebrae form the vertebral canal, which allows the spinal cord to pass through. So you can see that there is an opening there. Vertebrae are connected by ligaments from one to the next. So there would be ligaments connecting one to the next. So looking at vertebral anatomy, the body is a drum-shaped, that's the largest part on many of them. It is on the anterior side of the vertebrae, so it's facing the front of you, and it is what supports your weight of your body. So the bodies of the vertebrae are stacked on top of each other, which we'll be able to see that better if we turn the skeleton around later. And then the bodies of vertebrae are separated by masses of fibrocartilage for shock absorption and flexibility. So here you can see there are 2 vertebrae, and the bodies are stacked on top of each other, and there is the fibrocartilage forming shock absorbers in between them. So let's look a little more closely at the vertebra. So there is the vertebral foramen, which is posterior to the vertebral body. So this is anterior, and then going posterior, there is a hole, the vertebral foramen, and that is an opening in each vertebra for the passage of the spinal cord to go through there. Other foramens, there are other holes in a vertebral vertebrae in your spinal cord, and all the other ones allow nerves that radiate out from the spinal cord to innervate the body. Another part of a vertebrae are the spinous processes. These are bony projections on the posterior end, so this would be the posterior side, of the vertebra for muscle attachments. So you'll have ligaments and tendons attached there. And then there is the transverse process. These are lateral, so they're going out on each side, bony projections on the vertebra for muscle attachments. So you'd have tendons there. Other processes form joints with superior and inferior vertebra. So you can see these processes would form joints with the vertebra above, and these processes would form joints with the vertebra below. So let's take a look at the vertebral column. So we have the 4 curvatures: cervical, thoracic, lumbar, and pelvic curvatures. These are your cervical vertebrae, and we'll talk more about those. The vertebra prominens is on C7, and there's a bump on the end, the bottom of your neck, which you might be able to feel. And the thoracic vertebrae are going to articulate with your ribs, so they have facets to form a joint with the ribs. You can see in between all of the bodies of the vertebrae are invertebral discs, which are made of fibrocartilage. And then intervertebral foramen is the vertebral foramen. They all line up, and they make one large foramen for the spinal cord to go through, one big hole for that spinal cord to go through. And then also part of your vertebral column are the sacrum and coccyx. In our next video, we're going to go more in depth on each of the parts of the vertebral column and finish off the axial skeleton. See you then. Bye.